Hello everybody, this is Hima Bindu. I'm an application engineer with Best Engineering Aids and Consultancies Private Limited, which we dearly call Beacon. Um, so here I am today to talk about SolidWorks productivity tools, which will enhance your design work and yeah, make it quicker and easier. So let's jump right into it and so in the design process, beyond the 3D modeling, there's other aspects that need attention, like understanding the product performance, managing groups of people, cost and quality, collaborative design, communication, and so on. So, with all these aspects in mind, if you also have to focus on how the software is going to perform and figuring out the functionalities of the software, it takes up a lot more time and expands your design process. So, in order to minimize that time, I came up with an agenda to talk about few productivity enhancement tools like configurations, design tables, equations, SolidWorks utilities, Swift, which is SolidWorks intelligent feature technology, some more productivity tools, and design automation. So yeah, so if we say let's imagine we found a Harry Potter's wand which can do many things we wish for. So I'm hoping that these productivity tools will match up to that and we'll jump into the configurations, and I'm going to demonstrate what configurations can do inside SolidWorks. And I'm going into SolidWorks here, opening my file. So I've created a link already, and I wanted to show that the sketch can be modified and the equations can be added by just double clicking on the dimension and defining global variables. So just like that, a global variable is created for this value, and again I'm giving a relation with by using the same global variable length, and which will manage the other dimension, the radius of the edge of the link. I hit OK, and all these equations can be viewed from the tools equations window, wherein the length that we just created is displayed with its value and how much it evaluates to based on the equation. Similarly, the other sketch, the radius of the link is evaluated and the value is displayed. So I'm hitting OK. Now configurations. So if we go to the configuration manager tab here, we can right click and add a configuration. That's how different variations of a particular part can be created. I've created a configuration, and since it's highlighted, that particular configuration is active. And if we want to go back and make changes, we could do it from the feature manager tree or from inside equations also. So here I'm going to change the value to 180 for the length, and if you can see here, there are options to change that value for this configuration, all the configurations, or specific configuration. So I'm going to select this configuration here, and if I click one more time, I can see that the value for this other sketch has changed according to the equation that we've given. So I'm going to come out of the equations, and another way to modify the configurations, like to add a material or even add a configuration and change various other parameters, is by going into the modify configurations. Here I will try to create another configuration, give it a material, and similarly we can add the features here by just double clicking, going and double clicking in the feature manager tree or the graphics window, and we can suppress or unsuppress the value, the features in the modify configurations. So I'm going to suppress the value for um, whole wizard, and suppress here, say apply. Okay. It's saying whether we want the configurations to be linked to the display state so that those configurations can be displayed. Hit OK. Now, as we can see, there are slight variations in the appearance. That's because the configuration longer is active, and short has been given a color as well. So, the apart from those, we have another option to add or modify configuration, which is the design table. So, it can be sourced as a blank Excel sheet or auto create, which takes into concern the existing features of the model, and it also allows you to edit the control by allowing or blocking the model edits in the table, and few other options to add or remove the rows in the table. So when I hit OK here, the design table pops up, and it automatically takes all the configurations into account and the corresponding values. So here I am. So if you want to add more parameters into the tables here, you can go into the syntax for different columns, and those could be added manually and come up with the results. So that's about configurations. Now let's go back and see what we've learned. So inside configurations, we can create multiple variations of a part or assembly model within a single file. So it's a convenient way to develop and manage families of models with different dimensions and other parameters. So we can suppress and resolve different features, hide or show. We can also assign material and face colors, and change the size of the whole wizard properties. Coming to the equations, we could define the global variables and mathematical functions as well. And similar to the configurations, we can suppress and hide features, and also export equations to an external file to be used as a template. So in the design tables, which is another variation of the configuration, we can automate the dimensions by entering values in the table directly and coming up with the configurations. We can also use this Excel spreadsheet as design intent. So going next to the SolidWorks utilities add-in, I will demonstrate and see what can be done in there. So inside SolidWorks utilities, so it's an add-in basically where you can go to your add-ins under options and select the SolidWorks utilities. This utilities add-in takes care of comparing the documents and the faces, volumes, etc. I'm going to open my files here. And then can be seen inside insert or tools, and compare. So I'm going to the compare documents, selecting my files here, and so we could select from the options as to what kinds of units we want to use, and tolerances for the compare report. And in the features, we can select features tab. We could select the colors that we want to be shown for unique feature and modified features. And in the report, we could use only the current view, or you can specify the views. Here I have bottom and isometric selected, so I'll leave it at that. And geometry, you could compare these options before check the documents before compare geometry, and we can compare the faces and volumes of the reference document and the modified document. So I hit OK here, and all you have to do is select what you want to compare among the items to compare and run the comparison. So as you can see, it's comparing the volumes right now. And so so here we have our results where it's comparing the document size, mass, volume, feature count, and many more. So if we go to the compare features tab, it's showing the uh, unique features of each model, and we can spot those red dots, which if I click, show that the whole 9 in the bracket A is not there in the bracket B. Similarly, the fillet on hole is existing on the bracket A, while it's absent on the bracket B, and the same goes with this other red dot. So that's another comparison. And if we go to the geometry, we can see the comparison between the volumes, like the material removed in the modified document and material added, and common volume between the two models. And it comes to the face comparison, it gives the unchanged faces, unique and modified faces. So when you are ready with the comparison, you can go ahead and hit save, and give it a name, sorry, and location, and view report on save, and we hit save. So this is how our documents appear for different comparison methods. Say for document, there's different levels of comparison, and the mass, volume that we saw, it also represents the views that we mentioned. And compare features report, it again gives the report of the results we saw in the graphics area. And in the compare geometry, it compares the faces and volumes, and lists the same in the report. So I'm going to go back to my SolidWorks here. Now, so if we come back and see what we've learned, for compare geometry, we can compare features of two similar parts, analyze and group the features according to the unique and modified features, and then the results are also generated in the HTML report. Now in the features, oh yeah, so let's go back and see what feature paint basically adds the features that from the reference document to the modified document, or modifies the features. So compare bill of materials also, it lists the missing columns and rows, extra columns and rows, and the failed rows. So feature paint basically copies features from one part to another, basically reduces the manual design time. So now if we look into Swift, which is SolidWorks Intelligent Feature Technology, I will look into the Dim Expert, Dimension Expert, Fillet Expert, and Sketch Expert. So let me demonstrate the same. Um, so let's look into this bracket here, and what happens is in our feature manager tree, we could go to the Dimension Expert Manager and click on the Auto Dimension scheme, and select the part type, prismatic or turned, and then the tolerance type that we want for the part, plus and minus or geometric, and refer the datums here. So I'll go with this primary, secondary, and tertiary datum for this part. And from the scope, you could select all the features at once, or you could select certain features. So if I go with all the features, and feature filters, where you can select different features that you want the dimensions and tolerances for. And so the option is here where you can select all of them or some of them, and auto dimension basically, and that comes up with the dimensions. So in prismatic, what happens is basically the dimensions are positioned perpendicular to the datum axis. So while in the turned option, the dimensions are placed parallel to the datum axis, which I'll show you in a minute. So this is a turned part, and if we go to the dimension expert tab and select turned, maybe say geometric, and select the datum, here I just need two datums and all features. Hit OK. So we can see that the dimensions are placed parallel to the datum axis. So that's the difference between the prismatic and datum. Now prismatic and turned, I'm sorry. Now if we go back to the presentation, let's see, the next one is fillet expert. So if we have a part with lots of fillets in them, and say you want to change this corner, the way it is filleted, you can just click on the fillet and open the option for fillet expert. And as you can see, the faces are already selected, and upon clicking of shows alternatives, you can see the different options, and you can see the different options of filleting, and you can select as per your liking. So that's about fillet expert, and let's look into the sketch expert. So I have a model here with the sketch, and if I say which is fully built, when it's completely black, it means the sketch is fully defined. And say I suddenly decided to change the relationship between these two sketches, or lines, and hit OK, and I see that the sketch is over defined now. So how do I go back? If I go back and look at each and every dimension, that would take up a lot of my time. So I just double click on the overdefined here, and I see the option inside sketch expert to diagnose the solutions, to diagnose the problem, to find the solutions, and manual repair. So if we go to the diagnose, the SolidWorks does the analysis for you and comes up with several solutions, where you can look at what the solution is and what changes are being made. For instance, this red slash here is being suppressed in this solution, and if we look into all other solutions, and we could select the solution that we'd like to go with and hit accept, and that's how sketch expert could come in handy. So let's look into what we've learned about dimensional, all the Swift features. So dimensional expert automatically applies dimensions to features such as slots, fillets, or patterns in a 2D drawing. It also applies the correct dimensioning scheme and handles the location and spacing of the dimensions and it reduces an immense amount of time. So the fillet expert, it automatically fixes the fillets and drafts, reorders features so that other features do not have to be removed or disturbed. So inside Sketch Expert, you can automatically resolve dimensional conflicts in the design. Also, you can fix the over dimensioning of the model. So let's look into some more productivity tools, and start with FeatureWorks here. So I have a housing here. FeatureWorks is basically another add-in that you can turn on in the add-ins options. So what it does is basically when you have an imported part from some other software and you would like to come up with all the features, SolidWorks has a tool that will directly lets you select all the features. So it's under insert FeatureWorks, recognize features. So it lets you select the recognition mode. Say you want only certain number of or features, you can go with interactive, or you could select automatic, and SolidWorks does all the recognition for you. You can select the standard features and sheet metal, and or sheet metal features depending on the type of the model. And here are the automatic features that are available for such models. And if we go with interactive and select maybe fillet, we could SolidWorks lets you select the fillet, and there's an option called chain filleted faces, and that will automatically select the corresponding fillets that are linked to this original fillet or selected fillet. So that way it will, as you can see, the fillet option or feature has been created. So if we go back and do the same thing one more time, and this time we'll go with automatic standard features, select all of them, and hit OK. So SolidWorks is in the process of recognizing the features, and it's building the part all over again for you, and is listing the features in the feature manager tree. So it's as quick as that. So let's try the same thing out in another part which involves sheet metal features. So if I go to insert FeatureWorks, recognize features, here also you could select the interactive and select the sheet metal features, and then among the interactive features you could select the different sheet metal features available and recognize those. So I will go with automatic and see how it works. Insert FeatureWorks. So it is supposed to give you the FeatureWorks options, and sheet metal features, and then you could go ahead and select the different features that you want to create, and that will import all the or create all the features in your feature manager tree. So if we go back into the PowerPoint, the next one is thickness analysis. So for that, I have a little bucket open here, and what thickness analysis does is, inside tools, basically checks the design for us in terms of thickness. So you can look at the thin regions and give a limit for that, say 3 mm, and it looks in the model for all the thickness which is less than 3 mm, and if you go for the thick regions, you can give a limit there as well, and it shows the regions where the thickness is beyond 6 mm or whatever is specified. You can treat the corners as zero thickness, and you can give the color settings here, and for local analysis you could select the faces as well. So if I hit calculate, it would just do the processing and show me the thickness analysis that we just defined accordingly. So we can see that the red region is where the mm, thickness is less than 6 mm, and the greens are all less than 3 mm. So that's about thickness analysis. And close this file. I'll go ahead and close my files so that, sorry about that. So next in the list is design checker add-in. So for that, the design checker is another great tool inside SolidWorks, which lets the user to check the document according to or a drawing according to a standard that you have predefined. So if that standard is done by going into the build checks, you can create a new design checker, select the dimension and all these parameters according to your liking, select the units and such. And if I go into the drawing standard template, you could add a template, and that way the software would consider that template and verify according to that template. And then giving a third angle projection here, and save your template here. Save. Close. So I have a drawing open here. If I go to design checker and check active document, I could actually select a file from the one I just created, or yeah, anyway. So you could select the document that you've just created, and you could click on the check document, and the software does checks for you according to the reference document that you mentioned. So when it comes up with these errors or mismatched things, you could click on the autocorrect all, and it will show you a way to correct, or you could go into each one of them and see what the problem is, and vary the values accordingly. So that's about design checker. So another great tool inside SolidWorks is our toolbox, which I'm pretty sure all of you use for the most part. So the toolbox is inside the design library, where standard parts are already modeled for you, like screws, bearings, nuts, etc., in different standards. Worldwide standards. You can also configure the toolbox according to your liking, and you can give the user settings where you can create configuration parts and so on. So it also allows you to give permissions to each user, and change the values of the smart fasteners, etc. So that's another great tool inside SolidWorks that you could use on a daily basis in order to reduce your repetitive work. So another tool that is inside SolidWorks, which could come in handy, is the SolidWorks task scheduler, which is inside the SolidWorks tools program. So this is your task scheduler, which has several other options again to convert files. Say you just upgraded your software from previous version to the latest version, and you all your files are in the previous version. So you could select the files and add them to the list here, files or folders, and ask the software to convert them at your convenient time. You needn't do it while you are working on your design process. So the software does it for you when you're not in front of the computer. So similarly, there's update files option, where if you need few files to be rebuilt, and you don't want to open each file and rebuild it on your own manually, SolidWorks does it for you. So similarly, there are several other tasks that the scheduler can do, and you can schedule them at your convenience. So those are some more productivity tools that I came across. And another great add-in inside SolidWorks is the design automation. For design automation, it's called DriveWorks Express. Let's jump right into it and see how it works. So I have a mobile gantry open here. Um, so inside the Express products, we have DriveWorks Express here. So what it does is basically creates variations of files, of models that you have created, and you can use those variations in other files as well. So imagine if you have to create several files of the same build. Every single time you enter the same values and same custom properties. So instead of that, if you have a database, you might as well run it, and the software creates the model for you. So So in order to create that database, you select the create change database here and hit next, and you could save the uh, database at your convenient location. Hit OK. And then to add models, we select that, and we could browse for the new model, or since I have the model open here already, I would use the current open model option. Go ahead, and for the mobile gantry, I'm under captured assembly structure. The leg and universal beam can be selected. Um, Now there's other options like dimensions and features that we could define. So for that, I will open my universal beam first and go to the dimensions and features. In the feature manager tree, I have my right end selected here. So that dimension is listed here in the address upon selection, and I give it a name, beam length, and add. Another, let's add few more dimensions like boss extrude here. Selected that value and it's listed in the address. It took the address. I give that beam height, add, and let's go back to the captured models, mobile gantry, and select the captured assembly. We'll go into the leg part, and if I go to the dimensions here, so let's name that leg height, add, and this one to be minimum overlap, add, and let's add another feature here. So inner diagonal maybe, and then so these features and dimensions are going to be the variations of different other parts that we might create later. So that's definition of dimensions and features, and let's look into the custom properties for the mobile gantry. Or if we go back, that lists the captured assembly structure, and if I select the mobile gantry, I get an option to select the project safe working load. I go next, and here it's asking for us to list the form, basically define the form here. That way this pop-up comes up when the user wants to define the variations. So we are basically creating that form here, wherein so the first one would be project name, then I leave it at text box. You could add more here, and next one would be safe working load maybe, and then if we could change it to drop down and list options here. So these would be the options that the user could select from the list. So I go next, and we could add more, as many variables as we like. Opening height. We'll select a spin option in this spin button, and here we can give the minimum value, maximum value, and the increment that the spin that it can spin off. And then another variable, opening width, and then we'll put it as numeric text box where we could define the minimum value and maximum value. So the user enters the value between these two values. So hit next, and we have our variables here, and if we go next, it takes you to the rules window where you could define rules for file names, configurations, and everything else. So under rules, if I select edit file names and hit next, um, mobile gantry, I could the rule builder opens up, and you can give the project name. Hit OK. And then for the universal beam, there's a little tweaking to do here, but once you get the hang of it, it's pretty easy. So different logics and math can be added here. So it's a little bit of programming, but it's quite simple. It is basically the name of the project that we would like it to display when we create the new part. Working load. I want to basically name it with all the variables that are that we are defining, so that it's as clear as possible. Now the naming for the leg is remaining. We will give it project name, and then and project height, and then height, so that we know that's the height. So we've defined the file names. Now we'll uncheck this and edit the configurations. Um, so let's go ahead and edit the custom properties now. So under for the GAN, for the project, I'm going to select the project name. Okay, safe working load would be safe working load. Okay, and then back. Now let's do the dimensions, and for the leg height, it's going to be opening height. Okay, and then beam length is going to be opening width. Okay, and then beam height needs some definition, so needs a logic. So I go with if, and you can directly enter the logic. Safe working load equals 500 kg. So we're giving a condition here, and let's see how it works out. Hit OK, and then for the minimum overlap, it is again math safe working load. Okay, and then features, we could define the features for your diagonal. Give a logic here. If opening width is greater than 3000, then unsuppress it. So as you can see, you can create as many logics and conditions that you'd like, and this is all going to be the first part model, and for the remaining models, the software is going to automatically create everything, give all the values on its own. So this is basically a test, or yeah, you could name the project here, and then define the safe working load that we defined, and 1650 maybe, and then 1700, and you can create a model using those values. So as you can see, the software is creating the model, the assembly, with the values that we defined from the database we created. So this mobile gantry is all modified, and as we can see, the inner diagonal is missing here, and which we opted for based on the minimum overlap. So that took me around 10 minutes maximum to build the entire database, and yeah, I can create like infinite amount of models using the same database. So we go back here. So as we have seen, the DriveWorks Express, they are used to automate repetitive design tasks, reuse the existing designs, and generate new SolidWorks parts and assemblies very quickly and easily. I mean, configurations also do the same, but in DriveWorks, you can save the file size because you're not creating the configurations inside the same part, and then it's easy, very easy to use once you create the database, and you can share it with other people. You can also automate the drawings. As you might have observed that I did not open the drawing, and but the software can is capable of creating the drawings on its own when you define them. And then the rule, it is rules driven, so very efficient. So that those are all the productivity tools that I thought of sharing with you guys. Another tool is Photo View, which is used for rendering, editing the appearances and decals inside the software. So yeah, it is available with SolidWorks at all times. So it's a great tool for camera view, adding appearances to components, changing and editing scenes and lighting, and then save the final render. For this, in which case you do not have to have another software for rendering. So with that, I'm going to end the talk today. And if you have any questions, please do contact me over the email.
Question is available through chat. They can fill in the questions there. We will answer.
So the chat is open now. If you have any questions, you can type them in the chat window, and I will take a look at them and answer to your questions. So yeah, on the go to meeting webinar window, you will be able to see a chat or questions icon, and you can type in your questions there, and I will answer them as I get them. First question, is this webinar available for future reference? Definitely, we will send you a link with the recorded version of it, and you can take a look at it anytime you need it. And so the next question is, where will the DriveWorks store the new files? You can define the file location.
Increments the data.
It increments the data in the same folder that you have the previous files, and yeah, previous files as in the files that you used for reference. For instance, I had the mobile gantry open in my folder, and Once I'm done with using the DriveWorks, it automatically creates the folders or files in the same folder. Basically increments the models in the same folder. So the next question is, does FeatureWorks recognize complex commands like sweep and loft also? Absolutely. Any feature that is available to work with inside SolidWorks can be generated using FeatureWorks.
Yes, we do.
So
Yes.
yeah, you can import. So the next question is whether dimensional expert can be used for generating auto dimension in the drawing window. Again, the answer is yes. So once you open the drawing of the model that you created using the dimensional expert, there's an option to import the values, the diagnostics, and the dim expert is one of the options. So it takes all the values, all the dimensions from the model and displays it in the drawing according to the views that we select.